Welcome to our Orcharhino webinar. My name is Fabrice Plumule. I'm an IT consultant with ATIX, and today I will present you how to simplify patching with Orcharhino. For those of you who are expecting the different webinar, with APA presenting their experiences, this webinar has been shifted to end of April. As I had said, today we are presenting how to simplify patching servers with Orcharhino on Linux, independent of your operating system. So let me start with the following, the general idea. Why do we need to automate at all? There are several benefits of automizing. First of all, of course, is speed. So if you have to set up several servers and you have to do everything step by step, this is a job which can take several hours. If you have to set up many servers, this can even take several days. So by automizing, you just do one click. I can show you later on how to deploy a server with only 3 clicks, and everything runs automatically. Besides of speed, everything also becomes reproducible and stable. So you define a certain workflow, which is always run the same way. So everything runs stable because everything has been predefined and it's reproducible. If you have to do everything manually, so suppose you're setting up 5 servers which are supposed to be identical. You're doing everything manually. You have to set every parameter. You are setting certain configurations. You mistype somewhere, and then you end up with 4 identical servers and 1 server which has slightly less RAM because you mistyped. This all can be avoided by automizing your deployment and your configuration. The next is, of course, you can use configuration management tools to configure your host, to run your configurations, and everything runs automatically. So when your host comes online, it will be perfectly configured and ready to use. And last but not least, it enables you a self-service. So suppose you have a developer department and developers are developing their tools and their infrastructure and their packages, and at some point they break their server because something has been misconfigured. So in general, then they would have to open a ticket to redeploy their host, to repair it, and they have to wait until this is done. With Orcharhino, we provide a self-service. So in this case, you can allow a developer to redeploy his own server, and he can just do it with 1 or 3 clicks, as I said, and everything works, and nobody has to wait until everything has been rebuilt. So with Orcharhino, we support deployment on several platforms. The most generic ones are normal virtual machines. We support several hypervisors for that. The most common are VMware, Overt, KVM, or Proxmox. But we also allow deployment in the cloud. In this case, we would just deploy Orcharhino in the cloud or Orcharhino proxy, which then configures and runs the host for Orcharhino there. It's also possible to deploy hosts on bare metal servers. It's not asked that much, but this is also perfectly a valid scenario. So the next step we want to look in is configuration management. As I said, you are able to configure your host completely with Orcharhino. There are 3 configuration management tools that we support with Orcharhino. These are Puppet, Ansible, and SaltStack. These tools follow slightly different philosophies. Puppet is a server client system. In this case, it means we have a Puppet server where all the configuration of connected clients are stored, and we have connected Puppet clients on which a Puppet agent is running. This agent runs in general every half hour, inquires at the Puppet server what the configuration is, which is supposed to be on the client. If the configuration differs, it will be corrected so that it matches the Puppet server. If everything is fine, Puppet is happy and won't change anything. Ansible is slightly different. Ansible pushes your configuration via SSH, so it follows a fire and forget principle. SaltStack is a hybrid in this sense because you can run both scenarios. You can run SaltStack as a client master system. So you have a Salt master running on Orcharhino, and on the client there's a Salt minion running, which inquires in regular periods the configuration and correct it if it's different. But it's also possible to push your configuration via SSH to your client servers. So Now we get to the topic of today, a short overview. So basically, of course, you can do, and that's one of the main issues of Orcharhino, patch your servers. For this, we support basically every main Linux operating system. So you can see here that it starts with Red Hat-like systems, so Red Hat itself, Oracle Linux, CentOS, Alma, and Rocky Linux, but also SUSE, so SLAS, Ubuntu, and Debian. And the general idea to be able to patch servers is that we provide a repository. So in this case, you can create repositories in Orcharhino and mirror upstream repositories so that you can provide defined package states for your service. One important step with that, of course, is lifecycle management, which I will show you in the following slide. So if you have several life cycles, so let's suppose we have a standard scenario of development, testing, and production service. So you see it now in this slide. We can use so-called frozen package states. We would create a content view and publish a version, and therefore freeze the versions of your packages. So we can assign one of these frozen states to development, one to testing, and to production. And now the general idea is the following. So development, of course, will be the most recent package states. Testing is a bit older because then you still have to test until everything is unstable, and the oldest one will be production. So now we suppose we have developed packages running on dev service, and the developers say everything has been developed. Now we can introduce it for testing. We can take our content view version, which has been assigned to lifecycle development, and we can promote it as a whole to testing. Then the test server will be able to see exactly the same packages as a whole as the development server was seeing before. In this way, we avoid any dependency errors when upgrading the packages. The same can be done when the testing is done, and you say everything can be provided to production. You take just your content view version, which has been assigned to test, and promote it to production, and then all the production servers will obtain exactly the same package states as the testing servers were seeing before. This is one important point also to allow patching, because we have now very defined package states, and we can provide patches exactly for the versions which are required. One important thing is, of course, the following. So let's suppose that there has a CVE shown up, which is not included in the lifecycle a server resides in. So the naive idea would be that probably we have to prematurely promote a newer content view version to provide the patch. But this is not necessary. We can create an incremental update, and when a patch is required, which has dependencies which are in a newer version, we can just create a new content view version which is identical to the old one, and just including the dependencies which are required to apply your patch. So basically, you can even close your CVEs if the fix itself is not part of your life cycle yet. So basically, you see, the idea of Orcharhino is to map the whole lifecycle of a server, which starts with deploying. We have our config management, which runs to configure all the applications that are to run. And we have our release and patch management, which can be applied easily and centrally from Orcharhino. So to summarize, so what are we providing with Orcharhino? As I said, we support the deployment and patching for every main Linux enterprise system, but we also provide the deployment configuration management for Windows Server, as you can see here. The config management that we provide with Orcharhino can be done with Puppet, Ansible, and SaltStack. So you can use a combination of them, but if you don't want to use them at all, you can also skip all of them. We support running and deploying Orcharhino in normal hypervisors, as I said, VMware, KVM, Proxmox, but also the cloud, namely in this case, the Amazon Web Services, Microsoft Azure, the Google Cloud Platform. Being an enterprise solution, of course, for Orcharhino, we also offer support. There are different support models. The most basic one is the ticket-based support. So in this case, if there's a problem, you can open a ticket and our support will contact you and have a look and fix the issue. But there are also more sophisticated models. So basically, we also offer operational support. A more simple one that if you have a problem, you can contact us. we make a video session and we run services for you. And the more sophisticated one is that we even run it for you. So we tell you how to fix and how to run Orcharhino and do the job all for you. And as a support model, there's the standard support from 9 to 5. But if necessary, we are also able to provide support based on 24/7. We have an engineering department, which basically just is there to develop Orcharhino. This means we release new versions, we test them, we backport bug fixes. So Orcharhino is based on the open source platform Format Catalog, which basically is edge bleeding and sometimes has bugs which have to be fixed and normally will only be fixed in a new version. So we backport them, and this way we are sure that we only provide stable versions. But we also provide or develop new plugins. One example would be the SSC plugin, which allows you to synchronize user repositories if you have a user account. Or, for example, the snapshot plugin, which allows you, when you're running, for example, your servers on a VMware or a Proxmox, to snapshot your servers directly from the Orcharhino GUI. Last but not least, we also offer support, consulting, I mean. So basically, it's always a good idea to include consultants when setting up your Orcharhino infrastructure. Basically, it starts with an Orcharhino workshop where we talk with the customer and we have a look how the infrastructure looks like and give advice what's the best way to set up the infrastructure, what plugins will be needed, what configuration. And it's always good to have a consultant because there are plenty of plugins there, and it's good to know which ones are favorable and which ones do not bring so much benefit. And from consulting also, the training is being provided. So in general, so if you order Orcharhino, you can always order also training to learn how to operate Orcharhino to get the best benefit out of it. And this in general then is be done by a consultant. So all of this defines the product of Orcharhino that we deliver. In case that you already want to have a look on the documentation, we provide an upstream documentation, which is available on https://docs.orcharhino.com. So if you already have questions, we have a chat tool in here, so you can just type in your questions and I will address them. As the next part, I would just start with our Orcharhino demo, and I will share our screen and you will see our demo Orcharhino, and I will show you how to deploy a server and how easily it can be patched. Okay, now you can see the host page of our Orcharhino. You can see that there are plenty of servers in there. So you see many different operating systems, starting with Alma Linux, CentOS 7, Debian, Oracle Linux, Red Hat, Rocky, SUSE /12 and 15, Ubuntu, but also Windows servers. So you see there's a big variety. So let me show you how you can easily deploy a host. As I promised, you can do that with 3 clicks. So you see on the upper right, the blue button, Create Host. We just click on this. Now we get a form, which can be filled out. So in general, so we see here we have a name. We can keep that. In this case, we have to choose a host group where all the parameters have been predefined. I will show you a bit later what everything this means. In this case, let's just deploy Ubuntu server. So let's take an Ubuntu 20. So that's the second click. You see now, given from this host group, everything will be pre-filled out. And if I now click on Submit, the server is being built. So let's have a look on this server status, what we can see. So basically here we see the properties of a server. So we see the status, which is a summary of all the statuses below here. We see the host in the build because it's pending installation. We see the domain the host resides in. We see an IP address. In this case, we have defined that the host is connected to a salt master in a salt environment called base, which we can see here. The same way we see here that the host is connected to Puppet in the Puppet environment production and with the Puppet master, which is the Orcharhino. We see the MAC address, we see the architecture, and we see the operating system, which is being installed on the server. So as the server is being built right now, we cannot see that much yet. So let's just have a look on an already built server. So we go back to our host list and we have a look at one of the Ubuntu 20 servers which are already running. So the first bit you will see that we have our status, which I said is a summary of everything. In this case, the status of our server is error. So why is our server in error status? So if you go down here, we see here the value errata. So we can see that for this host, there's security errata installable. So we see this is something we do on purpose for our demo system because this allows us to show you how easily it is to apply a patch. More, we see here the configuration. It says no changes. This means the last configuration management run, Ansible, Puppet, or SaltStack was successful and did not change anything. In case that it was successful and did change anything, it would just tell you active. We see here the last remote execution, so a job which was pushed via SSH to your client server was successful. We see the server is fully subscribed, so it obtains its repository from orcharhino and is completely supplied with what it needs. We see here the traces which tell you if any service needs to be restarted or the server needs to be rebooted because one of the packages have been upgraded. So we can now have a look at the content of our host. So we go to the content host page here. So we can see that for our server, we already have 102 errata available. We see this content view has been connected to the content, this host has been connected to the content view composite Ubuntu 2004, and it is a testing server. As we see that the lifecycle environment has been set to testing. We see the activation key which has been applied. The activation key basically tells the server which repositories and subscriptions are to be assigned. If we go here to the subscriptions, here we see the products which have been assigned to the server. This is what has been done by the activation key. So we see this server obtains the repository for Cockpit, the Ubuntu client, which contains the packages which are required so the server can register itself to orcharhino and update the package states, SaltStack, Puppet, and the repositories for the operating system itself. So now we can have a look on our packages which are installed on the server. So if we go to dep packages in case of an Ubuntu, we can click here on installed. So here you see a list of all the packages in the versions as they are installed on your server. So we can have a look if the package Vim is installed. We see here Vim Common has been installed in this version. Furthermore, if you want to know if there are package upgrades available, you can just click here to the packages and applicable. Here you obtain a list of all packages which are installed for which a newer version is available. So for example, we see account service is installed on the server, but there is a new version available in the version 0.655. So we could easily upgrade this package. I will show you a bit later after I showed you how we actually provide the packages to the service. In addition, if you go to apt actions, you have a bit more variety what to do. You can actually install packages. So for example, if you wanted to install htop, you can just click on package install, package update in case htop already is installed and you want to update the package, or package remove in case you want to remove it. So before the next, what you can see here are a list of errata. So these are errata which are available for this server. So we wait a few seconds. It's taking a bit because there are quite a few. So we see here, for example, there's an erratum for GNU C library vulnerabilities. If we click here on the name, we can see the title. We see what it's about. We have a description. And we can see what packages are affected and to what version the packages need to be upgraded to solve the issue. So the question is, how do we provide these packages and all the states to the service. For this, we have a content section over here. So we can click here on content and on products. In the product, basically, repositories are gathered which have a common context. So let's have a look at the CentOS product, for example. So we have here one CentOS product. And now we see that we included 3 repositories. This is the US repositories, the updates, and the extras for CentOS. So if you click here on the name, you can see here the upstream mirror we are using to synchronize the repository. So we create the repository locally, we name the mirror where it's supposed to synchronize, we click on synchronize, and then on this path on your local orcharhino, you will be able to get the packages. So this is how everything will be synchronized. Ubuntu repositories look slightly different because the structure of deb repository is slightly different. So we can have a look on a deb product as well. So we go into one Debian product. So let's wait that our page has reloaded. So let's just pick Debian 11. So you see here we have 3 repositories, the Bullseye itself, Bullseye Security, and Bullseye Updates. And now if we click here on Bullseye Security main, you can see here we have the upstream URL, which basically goes to the path where everything has been downloaded. You have to name the release in this case and the component. And one thing which is important, which is only provided by orcharhino. So errata are a concept which tells you if there is a CVE, a bug fix, or enhancement for certain packages. By default, these are only provided by enterprise systems. So this would include Red Hat itself, Oracle, and SLES. In case of CentOS 7, we passed the mailing list and also are able to provide CentOS errata information for our clients in case of CentOS 7. Debian and Ubuntu are special cases. In the Debian world, the concept of errata did not even exist. So this is why we created an errata parser, which is parsing the mailing list in the security repositories for Debian and Ubuntu. And therefore, we're able to generate errata information for Debian and Ubuntu as well. So as you can see, we have an errata URL which you can add in orcharhino to your security repositories and therefore also get errata information. In this case, you see that for Bullseye Security main, we are providing at the moment 139 errata. So now we get to the frozen states. As I said, important part of that, of course, are first the life cycles. So we can have a look here at content and life cycles, lifecycle environments. So you can see here we have 2 different lifecycle paths. So you can structure your life cycles in a different way. So there are 2 basic philosophies. The one is the simple development, testing, production path. So basically you have a content view version with development, will be promoted to testing once it has been stabilized, and will be rolled out to production when everything has been tested and everything is rock stable to be run productively. A different version would be that you create certain states based on time. So for example, you have a content view version which has been frozen in Q1 2021, Q2 2021, Q3, and Q4. And then you can assign a server to be running on a certain step. So for example, I have a CentOS server and I want to tell it that it just uses the package states as they have been published in Q2 2021. In the first case, you would just promote your content view versions to point to the new life cycles. In the second case, if you want to update the content for your servers, you would just move your server to a different life cycles so that it gets a new version. So assigned to that, we get to the content views, as I told you. So the content views are the states where your packages will be frozen. So we go here to content and content views. And we see here, we have different content views over here. So let's wait that it has loaded. So let's have a look on our composite CentOS 7. So in our content views, we have assigned certain repositories. Once they have been assigned, we can just click here on Publish New Version, and the package states will be frozen in time. In this case, if we have a CentOS server, which is pointing to production. It will be connected to Composite CentOS 7 when we tell it to do it. And being a production server, it will obtain the packages as they have been defined in version 11. Testing and development servers will be pointing to version 13. So you see here that in this case, the servers will be explicitly getting newer versions. In this way, you can control your versions explicitly. So as I said, now let's suppose version 13 has been tested in a stable, and it can be used for production servers. You just go here on the button Promote, you select Production, and you click here on Promote Version. This is something which is going to take now a few minutes. Maybe it's quicker and taking a few seconds. You can see here the production order has been assigned, and once this promotion has been done, the production server will no longer be connected to the repositories from version 11.0, but to a version 13.0. Then basically, as I said, the assigning of your repositories happens with the activation key. We just will have a short look into that. So let's have a look at the activation key for CentOS 7 test. As I said, we don't have to define too many things. We just define a name, we define the lifecycle, and we define the coded view. With these three things, we have defined where the server is allowed to take its repositories from. The next step will be subscriptions. Here we actually assign which repositories are to be used by the server. So in case of a CentOS 7 test, it's only allowed to use CentOS 7, the CentOS client, EPEL, Puppet, and SoulStack. So then the server would just register itself to orcharhino, which is done automatically when deploying. It can be only done with already existing servers using the so-called bootstrap script. But in any case, this is the command which will be executed on the server. And once this has been done, the server will be attached to orcharhino and obtain its packages from there. So let's get back to our errata list where we stopped right before. Let's have a look if our server already has been built or a new one, or if we still have to stick to our old server. So we see our server from beginning of the session has been built. And as I said, we see here in our configuration, it's active because Puppet and Ansible ran already and changed the configuration. Now we can go here to content, and we can actually start to change our package states. So let's have a look first on our deb packages. So we see here, let's have a look at Vim. In this case, Vim is installed. Let's suppose we don't want to have Vim be installed. So we just go up here, apt action. We go here to Vim. We say remove. We click here on perform. And then a remote execution will be triggered. So the SSH and apt-get action. Here in the preview template, actually, we see what the script is, which will be applied. If we go back here and type on the name, we can see what happened on the shell. So we see here that Vim has been removed. Here we see now that the job was successful. And if you go back here in our package list and have a look at installed and look for Vim, we see that at least a few of the Vim packages have been removed. So these are actually VI packages. It's just named uncommonly, but this is perfectly fine. So now we can have a look at our errata. So as I told you, how errata look like. So let's see how easy it is to apply a patch, an erratum. In this case, we do the same like we did before. We just click here on the name. We click here on apply selected. When a remote execution will be triggered, we again have a look at our preview templates. So we see here actually what packages need to be upgraded for this erratum. We have a look at our server. We see here packages are being upgraded. Access status is 0, so it means everything was successful. You go back here. We list all our servers, all our errata, and we see the errata is no longer listed because it has been applied and is therefore no longer applicable. So let's have a look if you want to do it the other way around. Suppose you know that there are certain CVEs and you want to fix them on all affected servers. You can go here to Content and you can just click here on errata. Then all the errata which have been synchronized by orcharhino will be listed. So let's wait a few seconds. These are quite a few. So you see here, for all the operating system we are providing in our demo system, you have downloaded in total more than 30,000 errata. So we can filter them for applicable and for installable. So you might ask, what's the difference between applicable and installable? So by default, an installable erratum is also applicable. The difference is the following. In case that there is a CVE, an erratum available for a host, and the fix can be applied from the lifecycle the host resides in, it's directly installable and can be done. So let's have a look here, for example, for the SUSE server. We can have a look here. We click on the erratum, which is affected. We click here on apply. And now we get a list of all servers which are affected. So we see here we have two different /12 SP5 servers which are affected by this CVE. We just mark them. We click here on next and on confirm. And then the errata will be automatically applied on all the servers we have marked. Slightly more different is the case that we have errata which are applicable but not installable. This might be the case when you have now a production server. And now there's a package installed which is affected by a CVE, but the package version which is required to apply the patch is only available in a newer lifecycle. For example, testing, development, or library. In this case, the patch cannot be applied straightforwardly. That's what I meant before in the presentation with an incremental update. So let's have a look for applicable errata, but not installable. So we see here, in this case, for zlib, we have two servers where errata are applicable, but not installable. So now let's apply them. We click here on apply. We see actually these are both the same server, so we will get into a zipper lock. Let's have a look to a different one where we don't get a mismatch with an already running job. So let's have a look on this Python erratum for Ubuntu. So we click here on apply errata. So we see here we have now our two Ubuntu 20 servers which are affected by this. So we can just check them. We click here on next. And now it's telling us it wants to install, it wants to publish a minor version of our Ubuntu content view. So it is going to publish a version 13.1, which will be identical to a version 13, except for it will include all the dependencies which are required to actually apply this patch. So we click here on apply errata to content host. This means the minor version will be published, and as soon as it has been published, the patch will be automatically applied to the server. So we click here on confirm. We wait a few seconds, and then we will see that actually a minor version of our content view will be published or will be publishing. So this is something which will take a few minutes. So this is nothing we need to wait for. So let's wait that the job has been triggered. We can have a look at content views. We have a look on our composite Ubuntu 2004, which is right here. And we see here the version is being published and once it has been done, the servers will be shifted to that and will be automatically patched. Of course, there's also a way to generally update your servers. So in case you do not only want to apply certain CVEs, but you want to generally update your server from time to time. So let's have a look at our host list. So of course, it's a possibility that you just go on a server and start a remote execution. So let's do a basic one. So let's go to CentOS 7. You can click here on get a remote job. And just for example, let's trigger a command to see how easily it works. So we just do an update to see that it rises to the host. It's nothing to do with Patch Manager yet. We can have a look here, and we see actually on the shell that everything worked, so we can send commands. In this sense, of course, now we can just, of course, run a yum update -y, and then it would just update all the packages. Of course, it's quite tedious and a huge time effort to do it one by one. So let's not do it one by one. Let's do it as a bulk job. So we can have a look just on our CentOS service. We go here, select action, schedule remote job, and now we can just run a yum update on both servers. So at least now we can combine servers which are using the same package manager. So in this case, we have two CentOS servers. We could include also different Red Hat systems as Alma, Oracle, or Rocky Linux. But of course, then Debian and SUSE might differ from that. So in that case, we can also define our own job templates where we can define things to be run. So in this case, let's just demonstrate one example, and then I will show you what actually happens. So let's take our CentOS 7. Let's take a Debian 11. Let's take an Alma host and also a SUSE host, a /15 SP3. So we go here to select action, schedule remote job. So you have here different job categories. In this case, we also have a job category packages, where we defined a job template that we called update all packages. So now this job template will be executed. I submit it. And now this job template is going to run on all these servers simultaneously. So we can have a look what it actually does. So we go here now to host job templates. And we can actually see what this is about. So here all the job templates are listed. And this is where we created our script, update all packages. So you see as a first step, it's going to check what operating system it is. And then based on the operating system family, it's going to go into certain conditions and apply certain commands. So let's have a look how it looks like for an Alma. So on an Alma Linux, it's going to run a DNF update -y. On a CentOS server, it's going to run a yum update. On a Debian, it's going to run an upgrade update and an upgrade -y. And in case of a SUSE server, so let's look at /12, it's just running a zipper update. So you see, once this has been done, so maybe some of them will take a bit longer. So we see until now, Debian already was successful, has updated everything. So the other ones are taking a bit longer because they are a bit more outdated. And maybe we can have a look in 5 minutes which of them will have finished until then. Now here we can have a look on our Debian server. So it was for Debian 11. So we can remove a check here. So we go to our Debian 11 server. We see here actually traces reboot required. This is because we ran a generic update and there was also a kernel update. So we can go here to content. First at that package, we can look at applicable. So we see everything's up to date. Everything has been updated. There's nothing applicable anymore. If we go here to traces, we see that a kernel update was performed, which requires a reboot of the computer. So we just can click here on kernel. We click here on restart selected and restart. Now a remote execution will be triggered and will reboot the server within 1 minute. So in about 2 to 3 minutes, then we will see that the server will have been rebooted and the traces will have vanished. In case that you manually want to reboot your server, of course, you have also the option to go here via schedule remote job. You can go here into power. And now you can just define if you want to restart or shut down your server. Alternatively, if there are just servers to be restarted, you can go here to services. You name your service in this point and you tell to start, restart, or stop the service, or get one of the further options. So we can have now a look if one of the servers is still running. So let's have a look on how they look like. Let's have a look on Alma, on CentOS, on Debian, and on SLES. So we see here on our Alma host, the action is still running. So we are now in step 189 from 530. So this is going still to take quite a while. The CentOS server will be soon finishing. So let's close this one here. The Debian already finished, as we saw. And the SUSE server is also going to take still quite a while. So here we are waiting for the exit state, which is going to take probably still 1 minute. But basically, you have seen how easy it is to patch and update packages with orcharhino centrally, uniformly, quite easy. So basically, I am at the end of our live demo. In case that you have questions, just type in the chat. I will still be waiting about 1 to 2 minutes if some question arises. Thanks for your participation. Okay, apparently there were no further questions. So thanks again and have a nice day. Bye.